this video, we're going to go over the trigonometric functions sine, cosine, and tangent, which are often shortened to sine, cos, and tan, or sin, cos, and tan. So it's called sin, cos, and tan 1 because there are several videos in this series about sin, cos, and tan, and this is the first one. So I'm just going to quickly go over what these functions are, how we use them. Hopefully you've seen this before. I'm just going to quickly do a little refresher, but I'm not going to go into too much detail. So let's take a right angle triangle. So these functions relate angles in a right angle triangle to the sides of a right angle triangle. And we're going to look at how. So first of all, we'll take a right angle triangle and we'll mark one of the angles in it. So you can see we've marked an angle here, and we'll call the angle theta. And we'll call the three sides of the triangle O. That's for opposite because it's the angle opposite to theta. So all these sides are going to be labelled relative to this angle theta. So we've got opposite. We've got this side A for adjacent because it is the side adjacent to theta. I mean, there are two sides adjacent to theta, but this is specifically the one that isn't the hypotenuse, which is the third one. So the third one is H. It's the side opposite the right angle. It's the longest side in the triangle. It's always the hypotenuse. And the other two we define relative to theta, adjacent and opposite. I'm just going to remind you what these things are. So O is opposite, A is adjacent, and H is hypotenuse. And with this setup, we can define how we use sine, cos, and tan. So the function sine of the angle theta, so sine of theta, so theta is some angle, so it is some number, equals opposite divided by hypotenuse. So whatever the length of the opposite side to theta is divided by the length of the hypotenuse. So again, O and H are just numbers, they're just the length of these sides. Cos, on the other hand, cos of theta is the function such that cos of theta equals the adjacent over the hypotenuse. So the other side in the triangle that's not the hypotenuse is the one adjacent to theta divided by the hypotenuse is equal to cos of theta. And finally, tan of theta is equal to the opposite over the adjacent. So this time we don't have the hypotenuse at all, we divide the opposite by the adjacent, and that is equal to tan of theta. So you might have seen this before, hopefully, but a good way to remember this, because it's quite a lot of information, is with this sort of nonsense word, SOHCAHTOA. We say SOHCAHTOA, S-O-H, that's so or so, C-H-A, car, and then T-O-A, toa, SOHCAHTOA. Because if you look, say, at the first of these equations, the one with sine, we have sine theta equals O over H. So S equals O over H, S-O-H. So cos theta equals A over H, so C-A-H, car, and then T-O-A, tan theta equals opposite over adjacent, toa. So if you can remember this SOHCAHTOA, you can hopefully recall these equations. Okay, so let's try straight away applying this to a problem. So a person is looking at the top of a nearby building. They look upward at an angle of elevation of 32 degrees. If the person is 1.72 meters tall and the building is 5 meters away, what height is the building? So there's a lot of information there. Let's try drawing a diagram. It's always good advice to try drawing a diagram just on a bit of paper. It doesn't have to be neat, it doesn't have to look accurate. You just have to do a rough sketch and label the numbers that you have on the diagram. So start with a sketch. So that's the floor, and there's my person. So again, you'd be doing this on paper with a pencil, but principle's the same. I'm just doing it like this to save a bit of time. So there's my building, and I've got the line from person's eyes up to the top of the building. And we know that they're standing 5 meters away from the building. So this length here, the length from the person to the building is 5. We know that this is making a right angle. And we know that this angle is 32 degrees. That's given in the problem. So when we say angle of elevation, we mean the angle at which they're looking up, if you like, relative to the horizontal. So what else do we know? We know the person's height is 1.72 meters. So we have all the information we need to get the height of the building, because we just need the remainder. We know we have 1.72 meters, and then there's a bit more of the building before we get to the top. So how do we find it? Well, we're looking for this, the total height of the building, h. So that's what we want to find. We want to find h. Now, if we fill in this third side of this right angled triangle, so you can see I've drawn this side in red here, this is essentially what we need, because if we have this and we add it to 1.72, then we have the total height of the building. Now that we've drawn a diagram, hopefully you can see that. So we're going to call this O, this side we're looking for, because in our setup it is opposite the angle we have. So the angle we have, 32 degrees, the side we're looking for is opposite it. And what we have to think is, what other side do we have? The other side we have is the adjacent to the angle. So we don't have, you can see the hypotenuse, the longest side, we don't have that, and we're not trying to find it, so we forget about it. We have the adjacent, we're trying to find the opposite, so they're the two that we're concerned with. So which of these three equations on the left hand side has the opposite and the adjacent in? There's only one, and it's the one involving tan. So you can see that here. Tan of theta, the angle, is equal to opposite over adjacent. We have theta, we have adjacent, so the only thing we don't have is the opposite. So we can write that tan of 32 equals O for opposite over 5. So we've just plugged the information we have into the equation we have here on the left hand side, and we knew it was tan because we knew the problem involved the opposite and the adjacent sides to the angle. So now we just rearrange. So we get 5 times tan 32 equals the opposite. So I've just taken this 5 on the right hand side over to the left. And then at this point I'd use a calculator to figure out what tan 32 is, and I times it by 5, so you just plug that straight into a calculator and you get 3.12. So O is 3.12, but we're not quite finished yet, because we want to find h, the height of the building, so we know it's 3.12 plus the person's height, 1.72. And that is equal to 4.84 meters. So using one of these trigonometric functions, we have been able to solve this real-world problem.